Good morning all of you. So today we will start the law of a machine. So this is the chapter 5, which is simple machine. So according to the law of a machine, it is the term which is defined as the relationship between the effort applied and the load lifted. So for any machine, if we record the various efforts required to raise the corresponding loads, and after that by plotting a graph between them, we shall get a straight line AB as shown in the figure. So you can see this straight line, and these are the points which is the value of various effort required to raise the lifted load. So in the x-axis we have the weight, and along the y-axis we have the effort load. So now we also know that the intercept OA, that is this one, represents the amount of friction offered by the machine. Or we can say this is the effort required by the machine to overcome the friction before it can lift any load. So that by mathematically we represent the law of a machine as P is equal to mW plus C, where P is equal to effort applied to lift the load, m be the constant which is known as coefficient of friction, which is equal to the slope of the line AB, W be the load lifted, and C is another constant which represents the machine friction. So now there is a numerical based on the law of a machine. So here the question is, what load can be lifted by an effort of 120 Newton if the velocity ratio is 18 and the efficiency of the machine at this load is 60%? Determine the law of a machine if it observed that an effort of 200 Newton is required to lift a load of 2600 Newton, and find the effort required to run the machine at a load of 3.5 kilonewton. So here two cases are there. So that's why we have to solve this problem in two phases. So first of all, we need to write down all the data given here. So according to the question, the effort load is given as 120 Newton and velocity ratio is given as 18, and the efficiency of the machine is given as 60%. That means 0.6. And consider that W be the load lifted by a machine. So according to the case 1, the value of mechanical advantage is equal to, as we know that, W by P. So here W is not given, but P is given. So that's why W by 120 is the value of mechanical advantage. Then we know that efficiency is equal to MA by VR, that is mechanical advantage by velocity ratio. Now we can put the value of mechanical advantage here, which is W by 120. So we will write W by 120, and velocity ratio is given in the question, that is 18. Hence we can find out the W value from here by cross multiplication. So hence the W value is equal to 0.6 into 2160, which is equal to 1296 Newton. So for the first case, the value of W, that is the load applied, is equal to 1296 Newton. So now for the second phase, according to the law of a machine, for the second phase, the value of P is equal to 200 Newton and W is equal to 2600 as we got in the first case. So now, as per the law of a machine, we know that P is equal to MW plus C. So here, for the first case, the law of a machine is equal to 120 equal to 1296 M plus C, and for second case, 200 is equal to M into 2600 plus C. So we will mark it. This is as equation 1 and this is as equation 2. Then by subtracting the equation 1 from equation 2, we got the value of M as 0.06. Now we can substitute the value of M in equation 2. So by putting the value of M in equation 2, we can find out the value of C, which is equal to 44. Now we got the value of M is equal to 0.06 and C is equal to 44. So now we can write the law of a machine as P is equal to 0.06 W plus 44. Now we have to find out the required load. So now effort required to run the machine at a load of 3.5 kilonewton. So for that we have to substitute the value of W as 3.5 kilonewton. So by converting this 3.5 kilonewton in Newton, we have 3500 Newton, and we can put this value in this law of a machine equation, that means in this equation. So hence the value of P is equal to 0.06 into W, which value is 3500 plus 44. Hence, the value of effort load is equal to 254 Newton. Now another term is reversibility. So there is a reversibility of a machine, which means sometimes a machine is also capable of doing some work in the reserved direction after the effort is removed. Such a machine is called as reversible machine, and this action of reversible is known as reversibility of a machine. Hence, the condition of a machine to be reversible is that its efficiency should be more than 50%. That means if any kind of machine, if the efficiency is more than 50%, then we can say that the machine will be reversibility in nature. Now comes to self-locking machine. It is totally opposite to the reversibility of a machine. That means sometimes a machine is not capable to doing any work in the reversed direction after the effort is removed. In such case, machine is known as non-reversible, and simply it is known as self-locking machine. So here, the efficiency of the machine should not be more than 50%. So in this case, the efficiency should be less than 50%. So now we have to solve the numerical based on the reversibility and self-locking of a machine. So now the question is, a certain weight lifting machine of velocity ratio 30 can lift a load of 1500 Newton with the help of 125 Newton effort. So determine if the machine is reversible or not. So here in this question, the velocity ratio is given 30. The load, that is W, is given as 1500 Newton and the effort load is given as 125 Newton. So first of all, we need to find out the mechanical advantage. So as we know that mechanical advantage is equal to W by P. That means 1500 divided by 125. So the mechanical advantage value is 12. And after that, we have to calculate efficiency. So as we know that efficiency is equal to mechanical advantage by velocity ratio. Hence, the mechanical advantage that we got here 12 and the velocity ratio is given in the question as 30. So 12 by 30 is equal to 0.4 and by expressed in percentage we have to multiply 100 with 0.4. Hence, the efficiency of this lifting machine is equal to 40%. So here the value of efficiency is 40%, which is less than 50%. So that's why this lifting machine is non-reversible in nature. That means this is a self-locking type of machine, not reversible. Now, according to the lifting machine, there are many kinds of lifting machines are there, which are first of all simple wheel and axle machine. Next lifting machine is worm and worm wheel machine. Then single purchase grab winch. Then double purchase grab winch. And the last one is simple screw jack. So these are some lifting machine which we will discuss in next class. So today this much. Thank you.